Have you ever looked at the Burj Khalifa and wondered how something that tall can actually stay standing? At 828 meters, or 2,717 feet, the Burj Khalifa isn't just the tallest building on Earth. It's so tall that the top of the tower can experience completely different conditions from the ground below. It rises above the clouds, dominates the skyline, and has become one of the most recognizable structures ever built. But here's the surprising part. The greatest engineering achievement wasn't making the tower tall. It was solving dozens of problems that most people never even think about. Problems involving wind, heat, gravity, water, and even the ground beneath the building. Because without a series of incredible engineering breakthroughs, the Burj Khalifa might never have left the drawing board. And some of its most important secrets are completely invisible. Before construction began, many experts believed building this high would be far more difficult than simply stacking additional floors on top of a skyscraper. Every extra meter created new challenges. As buildings rise higher, they don't just become heavier. Wind forces increase dramatically. Elevators become more complicated. Water becomes harder to pump. Temperature differences become larger. Even tiny movements at the base can become massive shifts near the top. Engineers quickly realized they weren't simply constructing another skyscraper. They were entering territory nobody had successfully explored before. Dubai wanted a structure that would redefine what was possible, a tower that would break every previous height record and become a symbol recognized around the world. But before they could build upward, they had to solve a problem hidden beneath the surface. And this challenge would determine whether the project survived at all. Most people imagine the Burj Khalifa as the massive tower visible above ground. But the real story starts deep underground. Dubai sits on layers of sand and weak rock. While many assume sand alone supports the tower, that's far from the truth. An 828-meter skyscraper creates enormous pressure. Without a powerful foundation, the entire structure could slowly sink, tilt, or become unstable over time. To prevent that nightmare, engineers designed a gigantic foundation system using reinforced concrete piles drilled deep into the earth. Nearly 200 massive piles extend more than 50 meters below ground. Together, they anchor the building into stronger rock layers beneath the desert surface. The foundation alone required tens of thousands of tons of concrete. In fact, a significant portion of the engineering effort went into building something nobody would ever see. And while the foundation solved one problem, another threat was waiting above, a threat powerful enough to shake entire skyscrapers. Wind. For most buildings, wind is an inconvenience. For the world's tallest tower, it's a potential disaster. As wind moves around a tall structure, it creates swirling forces known as vortices. These forces can cause buildings to sway back and forth. The taller the building becomes, the more dangerous this effect gets. Engineers knew that a traditional rectangular skyscraper would experience enormous wind pressures. In extreme conditions, occupants could feel uncomfortable movement. In worst-case scenarios, structural damage could occur. So the design team came up with an ingenious solution. Instead of fighting the wind, they would confuse it. The Burj Khalifa's famous Y-shaped floor plan wasn't chosen simply because it looked attractive. It was carefully engineered. The tower features setbacks that spiral upward as the structure rises. Each section changes shape and width. This prevents wind from forming consistent vortex patterns. In simple terms, the building constantly changes its profile, making it difficult for the wind to establish a rhythm. Engineers tested hundreds of designs and wind tunnels before finding the optimal solution. The result was one of the most revolutionary skyscraper designs ever created, a concept known as the buttressed core. Three wings support a powerful central core, creating extraordinary strength while resisting twisting and bending forces. Without this innovation, the Burj Khalifa might never have reached its record-breaking height. But solving wind resistance created another challenge. How do you physically build something this tall? The answer sounds simple: concrete. The reality was anything but simple. Transporting concrete to extreme heights had never been attempted on this scale before. Normally, concrete becomes increasingly difficult to pump as height increases. Gravity works against every meter. At the same time, Dubai's intense desert heat created another serious problem. Concrete cures differently in extreme temperatures. If conditions aren't controlled properly, strength can be compromised. Engineers developed specialized concrete mixtures designed specifically for the project. Ice was added to help regulate temperatures. Many pours were conducted during nighttime hours when conditions were cooler. Then came the record-breaking challenge: pumping concrete higher than anyone had ever done before. Powerful pumping systems pushed concrete hundreds of meters into the air, setting world records during construction. Every successful pour represented an engineering achievement in itself. But building the tower was only half the battle. People actually had to live and work inside it. And that's where things became even more complicated. Think about it. The Burj Khalifa isn't just a building, it's essentially a vertical city. Thousands of people move through the tower every day. Residents live there, businesses operate there, hotels welcome guests, observation decks attract visitors from around the world. Supporting all of this requires incredibly complex infrastructure. The elevator system alone is remarkable. High-speed elevators travel at astonishing speeds, carrying passengers hundreds of meters in seconds. Without advanced elevator technology, moving through the tower would be impractical. Water presents another challenge. Every sink, shower, and cooling system requires water to reach incredible heights. Massive pumping systems move millions of liters throughout the building. Then there's air conditioning. Dubai's summer temperatures regularly exceed 40 degrees Celsius. Keeping a giant glass skyscraper comfortable in such conditions requires an enormous cooling operation. Engineers created sophisticated climate control systems capable of maintaining comfortable indoor environments despite the brutal desert heat outside. Yet perhaps the strangest challenge